So what is a linked list? First of all, a linked list is a way to store a collection of elements, which we've seen, like an array, right? An array stores a list of integers or a list of characters or a list of video objects or a list of your menu items or a list of your cars. So a list of anything. So a linked list is another way to store a collection of elements. Difference between a linked list and an array is in an array, you decide beforehand how many elements you want an array to have, and you allocate memory, whether it's dynamically or whether it's static, it doesn't matter, right? You have to tell it how many elements are going to be there in the array, and you create it beforehand or during runtime. You still create it before you start putting elements into it. A linked list is a little different. You build the list as you go, and which is where we use pointers, because pointers point to the next element or node and so on and so forth. So it is essentially another way to store elements, but it is nothing like an array. It's different from an array. So a node, for example, a linked list is formed using nodes. And what is a node? A node is one of these or one of these. Okay, these are two nodes here. This node has two things that belong to it. There is, let's take a look at the next slide to see what a node is. But before we move on, a node can have um, either it can have a list of integers or you can have a list of objects as well, which is what this really is. So here, the data that we are storing is an integer, and here the data that we are storing is a video object. So you can have a list of videos when I put all of these nodes together. Or if I put these kind of nodes together, I'll have a list of integers. Okay? So let's take a look in detail about this node. A node is a collection of two parts, two sub-elements. One is the data that we are trying to store. So a list of videos would have data to be a single video. A list of numbers has a single number. A list of characters would have a char here. So this data is what we want to create a list of. And this next, or this pointer, is a pointer that points to the next node. So we're going to have multiple nodes like this. If I want 100 elements, then I would have 100 nodes and they would all be linked. And I wouldn't create the 100 nodes before, but as I add elements, I would create the node. Okay. So how does this linked list work? So here's an example of a bunch of nodes that we have. So many such nodes linked together form a linked list. So when I'm ready to add a number 5, I create a node, I put the number 5 in it, I create a pointer. When I create the node, it actually gets created with the two parts. And I tell it that this pointer then eventually will point to the next item when I add the next node. Okay, so each node points to the next node in the order. This pointer will point to the next node when this node gets created. This points to 1 when 1 gets created. Well, I have no more numbers, so the last pointer points to null. So this is a null PTR that says my list is done. And at the beginning, we have a head pointer, which always points to the first node. So we must have a starting point and an ending point for an array, for a list. In an array, we know we have a starting point. It always starts at 0. And the ending point ends at our size, where we keep track of the size or the capacity of the array. So what are the operations that we can do by using a linked list? So the same things that we would do with an array. We can insert into an array. We've seen how to do that. We can delete from an array. We can display an array. We can search an array. So likewise, we're going to do the same thing with linked list. We may not have time to do all the operations, but we're going to try and do a couple of things. So we can insert into a list, we can delete from a list, we can display the list, and we can search a list. So let's start by first looking at how that node is going to be defined. How are we going to define this node that has two parts to it? We know when we have multiple parts, we can use a struct or a class. A node is going to be very simple. All it is going to do is it's going to get created and it's going to be part of a class. So we can make it using a struct. My node is my structure is called a node, which is going to be with a node. And I have two parts to it. In this case, the data is an int. Okay. So that's that name of the variable. It just has a capital D because it's a picture, but it's a variable. That's the same as this data. And next is a pointer, what is it going to point to? It's going to point to itself. So if you look on the previous page where we had this linked list, every pointer points to a node which looks just like itself. It points to the next node. So the next is a pointer that points to a node, the same type of a struct. It's going to point to another node. So next is a pointer to a node. So those are the two things that we have in our struct. Okay, before we see how to build our list, we are going to see how to actually walk down a list or traverse an existing list. Let's assume that we already have the list. It's easier to see how to walk down a list, or what we call traverse a list, and print something from a list. Then we will see in the next phase, we'll see how to insert into a list. So let's see that the list is already built. Let's assume that we have our list. We have our head, which points to the first node, and the last node's pointer points to null. And notice now I have put some addresses to this so we know how each one of these things is linked. Okay, so when this node gets created, it has an address 2000. When we connect head to it, the address of this node goes into head. Remember, head is a pointer. Pointers have address. By putting the address 2000 in here, we have said that head is pointing to this node. Now, we have a pointer here in this node, and that should hold the address for the next node. So when this node gets created, and the way we link it all, we are going to link it in such a way that the address of this node goes into this pointer, and so this pointer is pointing to this node. And likewise, 1500 is the address of the next node that goes in here, and that's pointing to this. So notice how the pointers are used to link these nodes by holding their addresses, and they could be in different parts in memory. They are not contiguous like your array, meaning they are not right next to each other in the memory location. Okay, and so here's 1200, which points to the next node, and the last node, there's nothing there, so it's a null pointer, it's all zeros. Okay, and each one of these, they're all called data and next. Okay, now here's how we identify these elements. When we simply say head, it's going to print the address that it holds. And to declare head as a pointer, if we say node star head, head is a pointer. It's going to point to an object of type node. You know how to create pointers. We've done that before. If you do int ptr, int star ptr, then ptr is going to point to an int. So likewise here, head is a pointer that is going to point to an object of type node. Okay, so this is just showing you how to declare it. It doesn't show you how to build it. There's a whole process. We build it, and it looks like this. Now, if I say head data, notice the pointer operator. Because head is a pointer, I can't use the dot, but I can use the pointer operator to get my data. So if I say head data, then I'm looking at the number 17. If I say head next, then I'm looking at the address 2800. If I say head next data, because next is a pointer that's pointing to the next node. So in order to get the next data, we would say head next data. And that looks like this. Head, the pointer operator, next data. And that would be 93. If I say head next next, that would have 1500. Okay, so if you look at the bottom of the table, I have head next next. So now we could go on like this, but it's going to be very cumbersome. So if I want to get 13, I have to go head next next next, then data. So we don't want to write code like that. That's going to be very difficult to read. And obviously, if my list has 50 elements or more than that, or whatever, then that's not a good way to do it. So let's see how to how to walk down this list. Can we move head? So let's see what happens if we move head. But if I want to move head, first of all, head was pointing here. If I say head equals head next had 2800. We take that and we put it into head. So now head is actually pointing to this node. But what are all the problems if we move head? We have lost access to the first node. How are we going to go back? Notice this pointer goes only in one direction. The pointer doesn't go back. So we can only go forward in a linear linked list. It's called a linear linked list, and we can only go in one direction. So we can't go backward. So from head, we cannot go back this way. We can only go this way. So now we have lost access to the first node, which is a bad thing. That's a memory leak. We know that if there is no way to access this and there's no way to delete it, and it's just going to get stuck there. Okay, so moving head is definitely not a good idea. So you leave head pointing to the first node. So what's another way? Let's have another temporary pointer. We can have as many pointers as we want. So let's have another temporary pointer, and you would declare that the same way you declared head. You would say node star current. Current is going to point to something, another node, so it'd be node star current. So once I declare that, I can say current equals head. So once my node has been declared and I say current equals head, that means current and head are pointing to the same node. Head has 2000. I take that and put it into current, and they're both pointing to the same thing. Now, the same table works. Current is 2000, so current data is 17. Current next is 2800. Current next data is 93. Current next is 1500, right? None of that has changed. But I can move current because it's a temporary pointer. And my head is still connected to the first node, and I don't lose anything. So by saying current equals current next has 2800. If we take that and put it into current, we have moved current to the next node. Then I could just say current data. Then I move current equals current next, and I print current data. So if you put this whole thing in a loop, and every time we move current equals current next, now it's just like stepping through an array. We are using a temporary pointer to step through an array. Like it says here, similar to I++. I++ works because I is a subscript and an array has all the elements right next to each other. But here we have current. I cannot say current plus plus because I would be incrementing the address, and that's not the right thing to do. But if I say current equals current next, then we take current next address and put it into current, and current is looking at the next item. So when I say current equals current next, this is how it looks. 2800 goes into current, and now current is looking at the next item. So now putting it all together, how do I walk through this list and print it? Let's say I want to display a list and I want to print it, right? So here's a list. So here's my struct. This is, again, we're putting it all together. This is how a linked list node is. I create my struct. I have an int data and I have a next. This is put together. That's just a struct. Now let's, in main, let's say I have created the linked list using this node. We will see how to do that later. But once the linked list is done, how are we going to go through and print it? So again, like I said, node star current will initialize the temporary pointer. Then you say current equals head. We initialize that pointer by starting it off at head. Then you say while current, here's my loop. Current, as long as current is pointing to something, right? That's what that says, while current. Or it would be, if you elaborate, it would say while current not equal to null or null PTR. You don't have to do it that way. You could simply say while current. That means as long as current is pointing to something. What do I want to do? I want to do cout current data. Current data will print 17 the first time. Then I move current. Current equals current next. Current next gets put into current 2800. It's now looking at the next one. If I do cout, of course, a while current has 2800. It has a valid address. So we're going to go into the loop and we print current data. Current is actually sitting here now. Current data is 93. 93 gets printed. Then it says current equals current next. 1500 gets put into current, which means we are looking at this address, which is 1500. Current data is 28 gets printed. While current is still true because it has a valid address. Then we move to the next one, 1200 gets put into current. So current is now looking at this node. While current is true, so we print 13. Then we move on to current equals current next. Now 000 goes into current. And the while loop becomes false, so we exit the loop.